Right, question 4. The flow diagram below represent the various organic reactions. Study the reactions and answer the question that follow. Okay. We'll study the reactions through the questions. First one, state the reaction condition required for reaction 1. Let's look at the reaction 1. So on reaction 1, if you look at that, we have a, what is this one? It's an alkene, and then from this alkene we are having an alcohol that is produced. So for us to have this, it means we must add this to H2O. So this will form a hydration. So when they're saying a reaction condition that is required here for us to produce alcohol, we'll need heat. That will be one of the reaction conditions. And then let's move to another one. Write down the formula of the catalyst used in reaction 2. Reaction 2, we're moving from alkene to propane. So a simple propane. So they want what? Name of the suitable catalyst. So the catalyst used in this addition reaction is, they said, a formula. So please, when they say formula, write the formula. When they say name, write the name. So it's the platinum, which is PT. Right, 4.3, propane reacts with excess oxygen. Propane reacts with excess oxygen. Write down a balanced equation for this reaction using molecular formula. So now, when we react with excess oxygen, it will form a combustion reaction. Combustion reaction. Now, under the combustion reaction, we know that we're going to take, they say use a molecular formula. So a molecular formula is, it means we're not going to show the bonds. So propane is C3, means prop, then H 3 by 2, 6 plus 2, H8, and then we're using the formula of CnH2n plus 2. That's why I'm saying 3. We have 3 carbons, so we're going to multiply that, not 3 by 2, we have 6 plus 2, going to have 8, so we have C8 plus O2. Then they'll produce, always they produce CO2, which is carbon dioxide, plus H2O plus H2O. Then for writing this only, you have your 2 marks, the reactions and the product. So make sure that you know what is being produced and then what is being the reactions. Right now we need to balance. When we're trying to balance this, what we're going to do here, normally we're taking the oxygen here. What should we do with the oxygen? Normally we try to multiply it by 2. Okay, firstly we take this number of carbon here, we multiply on the carbon dioxide, so we have 3 here, and then after multiplying here, what do you need to have? We're going to check the balance, we take the number on the carbon, we multiply on the carbon dioxide. So looking at that, we have C3, then we have 3 carbons both sides. And then what is left? We must make sure that we balance the hydrogen atoms. So we have 8 in here. So we have 4. So we have 2, then we can have 4 times 2 is 8. So what is left is the oxygen. So here we have 2. Let's check this side. We have 3 by 2, 6 plus 4. So we have 10. 6 plus 4 is 10. So what we're going to do with that, we have 2 here. Always you take this 2, you divide by the number of the carbon of the oxygen that are on the right hand side. So we're going to have 5. So it means we're going to have 5 oxygen there. Now it's balanced. So that will be our combustion reaction balanced. Use structural formulae to write a balanced equation for reaction 3. What is reaction 3? It's here. So they say use structural formulae, strictly structural formulae. So we can let's put it at the top here. So this is reaction 3. So we're going to have 1, 2, double bond carbon. Then this is what we have, hydrogen here. Then hydrogen, 1, 2, 3, 4, 2, 3, hydrogen here, hydrogen, hydrogen, hydrogen. Plus, now because there's a structure, we're going to break this into structure where we have H bonded to chlorine. Now this will produce, let's write the production here. So how many? Let's do this. So let's write the answer here. This will produce how many carbon here? 1, 2, 3. So we have 1, 2, 3. Now the double bond was here. So now we'll break to this carbon and to this carbon. Then what we have, the hydrogen already left this breaking. Now let's put it like this. We have the hydrogens, hydrogen, hydrogen. Now the rule says the hydrogen must go to where there is high number of hydrogens. So which one is having high number of hydrogens between these two carbons where the bond was? So it means the first carbon here, which is having a hydrogen here. So the Cl will come at the center here. Now this is a major product. So our having our reaction like that, it's balanced. A structural isomer of the product of reaction 1 is reacted with butanoic acid to form an ester. What I'm saying, a structural isomer of the product of reaction 1. Here it is. And then there's a structural isomer, not functional, structural isomer. What can we do the structure? We can only move this OH position, and then that will change the structure, because there is no way you can change this structure here than removing this OH to put it at the end and put the other hydrogen there. So they simply said structural isomer. So we don't know whether it's positional or, but the correct name there, I think, would be the positional isomer, but they said structural. So we can agree with 3 types. We have the chain isomer, so we cannot change the chain here. We have positional, but this position of OH can be changed. And then we have the functional, so we cannot change the function here. So there's only OH that can move. So meaning the isomer that I talk about, there will be C carbon, carbon, carbon O bonded to H, and then now we'll have the hydrogens here. Right, that will be the isomer. The says it's going to react with the butanoic acid. What is butanoic acid? 1, 2, 3, 4 carbons. Then this other one is going to have oxygen here. Then oxygen bonded to hydrogen here. And then 1, 2, 3, 4. Then what is left here? We need to fill in the hydrogens. Right, this is the butanoic acid that we're going to have. Now they're saying the two will react to form an ester. Write down the name of the catalyst used in this reaction. So we need an acid here because they are saying name, not the formula. So the name is sulfuric acid. So it is sulfuric acid. Right. Number 2, they are saying write down the structural formulae of the ester formed. Now they want the structure, and then the structural formula of the ester formed. Now we're going to take this. We're going to take this oxygen here and this other oxygen here. Now what we're going to do, we're going to take these 3 carbon atoms bonded to these 4 carbon atoms with by 1 oxygen. So fine, let's do it like this. Let's write the first carbon atoms for this side. So we're going to have carbon, carbon, carbon. This is coming from the alcohol. Now they must be bonded to these 4 carbon atoms through oxygen. So 1, 2, 3, 4. So now the carbonyl was coming from which one? Was coming from these 4 carbon atoms. So the carbonyl must continue being here. Then what is left now is to fill in the hydrogens that were there. So we can have 1, 2, 3, 4. So we can have hydrogens to be filled here. Hydrogen, 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 hydrogen. Right, that will be the structural formula of the ester that will be formed. Now the name of the ester, of course, we name from this part. That will be propyl. Then now this one will be butanoid. Butanoid. Now that will be the name of the ester that is being formed. So the one that is coming from alcohol will behave as a branch that will be having an aisle. That's why I said propyl. Then this one of acid will be taking the ending name of anoid. So it's a butanoid. Right, that's what we have for question number 4.